हमारा जो आज का टॉपिक है और टुडेज टॉपिक इज क्वांटम मैकेनिकल ट्रीटमेंट फॉर लीनियर हार्मोनिक oscillator. For 1D, one-dimensional linear harmonic oscillator, the Schrödinger wave equation becomes H psi is equal to E psi, where H is kinetic energy plus potential energy, psi is equal to E psi, and value of kinetic energy is minus H square over 8 pi square into m d square by dx square प्लस v टू साई इक्वल टू ई साई। हम ये जो यहाँ पे डी स्केयर बाय डी एक्स स्केयर लिखे इसको ऐसे डेल स्केयर बाय डेल एक्स स्केयर लिखते हैं और प्लस डेल स्केयर बाय डेल वाई स्केयर लेते हैं जब हम लेते हैं 3 डायमेंशनल में, और जब हम 1 डायमेंशन की बात करते हैं तो हम प्योर डिफरेंशियल लिख सकते हैं। ओके, ये जो इक्वेशन है इसको 1 इक्वेशन मान लो। नेक्स्ट मैंने जो फर्स्ट वीडियो डाली हुई अपना फर्स्ट लेक्चर लीनियर हार्मोनिक ऑसिलेटर पे, उसमें मैंने किया था क्लासिकल ट्रीटमेंट ऑफ LHO लीनियर हार्मोनिक ऑसिलेटर। वहाँ पे हमने वैल्यू निकाली थी फ्रॉम क्लासिकल ट्रीटमेंट वी हैव V इक्वल टू 1/2 kx square. Okay, then put this value of V in equation 1, and then we get minus square by 8 pi square m d square by dx square plus 1/2 kx square. Put this in bracket, psi is equal to A psi. This is our second equation. A close examination of above equation show that the above Schrödinger equation is very much similar to the particle in one-dimensional box. Here is only one additional term, that is half kx square. We will solve this equation by the factorization method. For that, first we will define the boundary conditions. The boundary conditions here is that this is one-dimensional box where V is equal to 0 inside the box, and value of x vary from minus infinity to plus infinity. Okay. First we will convert this equation into appropriate form, then we will factorize it. First I am writing this equation in very simple form, 8 pi square m d square dx square. We are taking into x direction, therefore I write here x plus 1/2 kx square into psi x into psi x. You can also write this at minus h square by 8 pi square m is h cut by 2m. Okay, we will get this simple equation. Then multiply this equation by minus 2m by h bar square. You can also say h cut square. This is similar. If we divide this equation by minus 2m by h cut square, this will cancel out. Okay, this will cancel out, and we are left with d square by multiply this equation with minus 2m over h cut square. This identity. This will cut out, and we are left with into minus 2m over h cut square. Okay, then you will get this equation minus m h cut square kx square psi into x e psi x into minus 2m over h cut square. Okay, then we know that omega is equal to 2 pi nu, and in the first lecture I have find out the equation of this nu from the classical treatment of LHO. This is comes out to be 1 by 2 pi under root k by m. Then put this value of nu into this equation. W equal to 2 pi will cut out, and under root km, and we are left with k equal to omega square into m. Put this value of k into this equation. Into this one equation. Here you will put the value of k, and we will get d square psi x or dx square minus omega h cut square omega square m into kx square psi x ex multiply minus 2m h cut square. Then d square del square psi x or del x square minus multiply it with m into m square h cut square omega square into x square psi x into minus 2m by h cut square. Okay, and multiply this equation by h cut by mw. When you multiply this equation by h cut by mw, we are left with h cut by mw d square by psi x into dx square minus m omega over h cut into x square psi x is equal to e psi minus 2m multiply minus 2m h cut square. Now put the value of m omega h cut into x square equal to y square. When you put this value here, then we will get this equation. H cut m omega del square psi or del x square minus y square psi equal to minus 2e h cut omega into psi. Then for the solution of above equation, we can write this identity as ddx into d psi over dx. Okay, then again we can write ddx into d psi over dy into dy over dx. Okay, here we put y equal to this one m omega or h cut under root into x. Then put if we differentiate this equation dy by dx this will remain same, m omega by h cut 1 by 2, and dx by dx become 1, and we are left with this equation. Take dy by dx is equal to a over h cut 1 by 2 and a square equal to m omega by h cut. Okay, here we have d dx into d psi over dy into dy by dx. Then dy by dx, what we have put? This is equal to a. Put the value of dy by dx here, a. Then again by opening this differential into dy by dx into d psi by dy into a. This is again equal to a. A into a is a square, and we are left here with dy into a square, and this equation comes del d square psi over dy square into a square. Okay, then put the value here. A is what? A square is what? M omega over h cut. Put this value of d square psi over dx square into this equation, wow equation. H cut over m omega, this is equal to d square psi over dy square into m omega over h cut minus y square psi equal to minus 2e psi over h cut into omega. Then by cutting this, we will get d square psi over dy square minus y square psi minus 2e psi over h bar omega. And then by taking psi common, we are left with this equation, and we can also put d square by dy square minus y square psi equal to minus lambda into psi. This equation can be easily factorized. In next video, I will tell you how to factorize this equation. Thanks for watching.